Now in this video we're going to learn how to reduce fractions and multiply them. So let's just go over some examples. We know how to reduce, and we also know that fractions are really division problems, right? So we should all know that 4 over 4 is really 4 divided by 4. And what's 4 divided by 4? 1. So whenever you have a 4 on top and a 4 on the bottom, that technically cancels out and it becomes 1, right? So it's not that they cancel out and they disappear. It's that they cancel out and they become 1. So what if I had 12 over 4? What's the answer there? 3. The answer is 3, right? 12 divided by 4 is 3. However, I want to show you this different angle. Let's say I took the 12 and I rewrote it with multiplication as 4 times 3. Okay, because 12 is really 4 times 3. And if I put that over 4, then I have a 4 up on top and a 4 on the bottom. And that goes back to 4 over 4 is really what? 1. So the 4's cancel. So you really have a 1 up here and a 1 down here. So that's really 3 over 1, which is just 3. I know you're thinking, why the heck do I want to do all that work? Honestly, it's pointless to do that work. If you already know that 12 divided by 4 is 3, that's your answer, and that's all there is to it. But I'm showing you this because it will help us in the future when we get to factoring, and also when we get to multiplying fractions, that we're able to cancel whatever's alike up on top and on the bottom, we could cancel it out, right? It doesn't matter what it is. If you have a negative 3 over a negative 3, it cancels, it equals 1. If you have a square root of 7 over the square root of 7, it cancels, it equals 1. They cancel out, it equals 1. If you have happy face over happy face, it cancels, it equals 1. Seriously, anything over the same exact value, it equals 1. And that's a very important fact when it comes to reducing fractions and also when you're multiplying fractions. Let's do a multiplication problem. Actually, before doing a multiplication, let's do one that requires reducing. Let's take a look at the fraction 4/6. Now, we all know how to reduce. Normally, we reduce by doing what? What's the thought process? Dividing by what? By 2 in this case, right? So you could divide by 2, and you will get 2 over 3, and that is your reduced answer. But here's another option. The 4 over 6, you could change the 4 to look like 2 times 2, and you could change the 6 to look like 2 times 3, and then you could say, oh, the 2 on top and the 2 on the bottom cancel out. And your answer is 2/3, right? Why would you want to do that? You probably don't want to do that. But it's good to understand it because, like I said, many things that we're going to cover in the future in this class, it's good to understand how they cancel out like that and they become 1. Let's actually now multiply 2 fractions. So let's put the fraction, let's say 2/3 and 4/5. And let's multiply. Now, a lot of students get really confused with multiplication of fractions. And it's funny because multiplying fractions is like the easiest thing. So what do you guys say? How do you multiply fractions? You just go right the top with the top and the bottom with the bottom. Multiply the numerator with the numerator and the denominator with the denominator. Okay? Some students say cross multiply. No, don't cross multiply. That's when we're solving proportions when you have a fraction equal to a fraction. Some people say, I don't know, they just get some really crazy ideas. It's really simple to multiply fractions. You simply take the top number and multiply with the top number. 2 times 4 is 8. And 3 times 5, the bottom with the bottom, is 15. And then, of course, you're supposed to try and reduce. But 8 over 15 cannot be reduced. You can't reduce by 2, can't reduce by 3. That's it, you're done. Easy peasy? All right. Now, what if I had, let's say 2/3 times 1/2. Yes, I could multiply the top with the top and the bottom with the bottom. What would I get if I actually did that? If I went 2 times 1, what do I get up here? 2. And then 3 times 2, what do I get? 6. But you have a fraction 2/6, right? And that could be reduced. What does it reduce down to? 1/3. So we know our final answer would be 1/3. So I guess what I'm trying to get at here is you could multiply the top with the top, bottom with the bottom, and then reduce. Or you could reduce first and then multiply. Now, what do I mean by reduce first? If you look at the fraction 2/3 and the fraction 1/2, up on top you really do have a 2. And on the bottom you really do have another 2. So if you have a 2 on top and a 2 on the bottom, that's like saying 2 divided by 2, And we know that that cancels out, right? So the 2 cancels with the 2. They're not there anymore. So what do you have now? You really have 1 times 1, that's 1, and 3 times 1, that's 3. So you have the answer 1/3. So it's the same exact thing. Like, you don't have to do the canceling, right? But canceling might be a little easier for you. Or maybe not. Maybe you really do want to take the 2/3 times 1/2 and multiply. 2 times 1 is 2, 3 times 2 is 6, and maybe you like reducing by 2 and you get 1/3. So same answer, it's just offering you a different angle, all right? So canceling is really easy. Let me show you another one. So if I have 3/7 times 7/9, I could multiply 3 times 7 and get 21 up on top, and 7 times 9 and get 63 on the bottom, and then I could reduce, but it's probably a little easier to reduce first, especially because I have 7/7. Anytime you have the same exact value on top and same exact value on the bottom, you could cancel those out. It becomes 1, right? 7 divided by 7 is 1. So let's just cancel out those 7s. They become 1. And then I could multiply 3 times 1 and 1 times 9 and get 3/9 and then reduce. Or I could simply say, okay, 3 right here and 9 down here. I could reduce 3/9. What does 3/9 reduce down to? 1/3. I could reduce 3 by 3 and reduce 9 by 3. So if I reduce 3 by 3, 3 divided by 3 is 1, 9 divided by 3 is 3. So that's where I get the final answer, 1/3. So you see, I think, especially on these cases, canceling out makes the problem a lot easier when you're multiplying fractions. Because you could have multiplied 3 times 7 and gotten 21, and then 7 times 9 and gotten 63, and then you could reduce, and you should be able to reduce to that same exact answer, 1/3, but I think canceling is easier, for me at least. You don't have to cancel. You could multiply top with the top, bottom with the bottom, and then deal with reducing that if you want. But this is the final answer. I think it's easier. Let's go to multiplying a fraction times a whole number. Give me a fraction, anybody? Any fraction. 2/5. 2/5 times, and give me any number you want. 3. Why not? Okay, so I have 3 times 2/5. Well, multiplying fractions was easy, top with the top, bottom with the bottom. But what do I do with this 3? It's not a fraction. Put a 1 on the bottom, make it look like a fraction, right? So let's put a 1 on the bottom, and then we just do what we normally do. 3 times 2 is 6. 1 times 5 is 5. 6/5 is your answer. That's an ugly 5. Let me fix that. 5 right there. 6/5. That's an improper fraction. You could change it to a mixed. I'm fine with improper fractions. But if they did ask you to change it to a mixed fraction, 6 divided by 5, because that's what the 6 on top over the 5 actually means. It means 6 divided by 5. Well, that'll go in one time without going over. And when you subtract, you have a remainder of 1. And what do we do with this remainder? We put it over the original divisor. So I'm going to take that remainder and put it over the original divisor. So the mixed fraction would be 1 1/5. So just in case you forgot how to change an improper to a mixed, that's how you do it. So why am I going over this? Because on the worksheet I gave you Friday, we have some similar situations to this. Like on number 13 on the multiplying. Right here we have a fraction, 3/5, and we have a whole. Actually not a whole number. This is actually an integer, -15. So you could put that integer over 1, and then you could cancel out the 15 over the 5, right? Because if you have a 15 up on top and a 5 on the bottom, that's like 15 divided by 5, or 15 over 5. What is 15 over 5? 3. So if I take the 15 and the 5, I'll have a 3 left over up on top. And let's not forget that it's negative. So I have a -3 instead of a -15. And then on the inside of the parentheses, I have a regular 3. So I really have a -3 times 3. That's a -9 as a final answer. Number 14, I could put the -20 over 1. And I could cancel things out. Oh yeah, here's another option, guys. You could deal with the signs before even multiplying or canceling or dividing. What is a negative number times a negative number? Positive. So you already know your answers are going to be positive. So you can just forget about that negative and that negative because you already know that a negative times a negative is positive. And now you could focus in on the 20 that's up on top and the 4 that's on the bottom. 20 over 4 is what? 5. So the 20 and the 4 become 5, and the 5 is clearly up on top because the bigger number 20 was up on top. And now we simply multiply 5 times 3 and get what? 15. And on the bottom there was nothing left. I mean, you could say 1 times 1 if you wanted to, but 15 over 1 is still 15, so the answer is positive 15 for that one. Anyway, I hope we have a better understanding for fractions. Sometimes a fraction simply means to divide, like right here, it's -5.
Game time.
Yeah, game time. Okay, so I hope this video helps you guys.